I'm Joe Bruin. Represent! You've seen me in such fine quality chemistry educational videos as titration, what do acids and bases have in common? And what's the pH of that acid base? Okay, we're going to be looking at how do you determine the pH when you're mixing a weak acid or base with a strong acid or base, because the system's the same in both. Now, if you're combining strong acid with a strong base, different system on how to do it. And remember, when we look at strong and weak, weak meaning it doesn't dissolve very well in water, whereas strong, it dissolves totally in water. That's the difference. So for our problem, we're going to look at good old-fashioned acetic acid, 50 milliliters of 0.1 molar acetic acid with 25 milliliters of 0.1 molar NaOH. What is the pH? That's our question. Well, there's some things that we have to look at. When you're combining a weak acid or base with a strong acid or base, okay, you're going to have to use stoichiometry. In other words, you're going to have to change the thing to moles. Then you're going to have to work out the new concentrations as a result of that. Then the second step, you're going to use the ice. Notice I did that in blue on purpose. And then the last thing, you're going to find the pH. Okay, now, on with the thing. So let's take a look. Let's look at our stoichiometry. We had 50 milliliters, okay, and 25 milliliters. So 50 milliliters of our acid times 0.1 molar. So our concentration, remember, it's moles over liters. So if we multiply our concentration times our volume, that gives us the moles. So we've added here 0.005 moles of our acid, 0.0025 moles of our base, our strong base, our NaOH. Now the next thing we have to look at is that NaOH is going to cancel out, is going to remove protons from the solution to begin with, because it's going to join with them and become water, which is going to have an effect on the pH overall. So we've got to take that into account. This is why we had to change it into moles. Now we're going to have to find how much damage does the OH do. How many of these H's does the OH take out? So we have before reaction, these are our moles, okay, 0.0025 of our NaOH, and again, Na, sodium, doesn't figure into this, okay, it's a spectator, if you will. And then here is our acetic acid, our acid, okay, and this is our reaction combining these two, and we got our acetate. Now we're not worried about the hydrogen at this point because it's close to zero. So this is what we have before the reaction. When the reaction's done, we're going to lose this 0.025 moles of OH, and so will our acid, because our OH will take the proton from the acid, so that's why we're going to have 0.0025 left. Our acetate on the other side, if it's lost here, it gains here as well. So the bottom line is, for our new concentration, okay, we have our moles divided by now the total volume when you took the 50 milliliters of the acid and you added 25 milliliters of the base. So you have 75 milliliters total, so that gives us 0.075 liters, okay? And now we have our concentration. Our concentration of our acid and our concentration of the acetate, okay, to begin with. Now we're ready. We've done the stoichiometry. We've figured out, we changed it to moles. Then we looked at how many moles of the hydrogen was going to go by, because it's going to combine with the OH. Now we have new concentrations. Now we're ready to go and ice it. Okay, so here's our ice table. Here's our acid. And we said, wait, where's the base? Well, the base already canceled out. The base already did damage to the acid. It canceled it out. This is what's left. This is our remaining acid that has not come in contact with the base, and it breaks off into our hydrogen ions and our acetate ions. So here's our initial, 0.033 molar, 0 initial concentration of hydrogen, our acetate, 0.033 molar, okay, minus X, that's going to be our change, right, because we're going to lose here, we're going to gain on this other side, and we're going to gain here as well. So our equilibrium, we're going to assume that X is really small, okay? So we have 0.033 X and 0.033. So here's our acid concentration at equilibrium. Here is our hydrogen at the concentration equilibrium. And here is our acetate concentration equilibrium. And as you know, to find Ka, our acid dissociation constant, which they give that to us, it's 1.8 times 10 to the minus 5th. Products over reactants, so that's what I did over here. The 0.033s will cancel each other out. That would be kind of important. So our X will equal 1.8 times 10 to the minus 5th. So now we have our equilibrium concentration of our hydrogen ions. The next thing we got to look at, ladies and gentlemen, is how do you figure out the pH? Well, the basic formula for pH, you might remember that pH is the negative log of our concentration of hydrogen ions, which in this case, ladies and gentlemen, the negative log of 1.8 times 10 to the minus 5th, the pH is 4.74. Okay, at this point, we're done here, and I hope this helps you guys out. And I will catch you guys on the flip side. I'll make another video dealing with strong acid and strong base, which is actually less complicated than this. You only use the ICE table when you're dealing with a weak acid or a weak base, and you're combining with a strong acid, strong base. That's how it works. All right, guys, take care.